Okay. I think we should be ready now. So yeah, first of all, I think I'd like to thank you all for tuning in to our webinar today. I'm very happy to see everybody joining. And yeah, I think we would just kick it right off then. I would start with a little introduction on my side. So my name is Leah, and I am part of INEOS Styrolution's sustainability team, and I am the one responsible for all of our mass balance activities at INEOS Styrolution. I have my colleague Johannes with me today. So yeah, I think Johannes, you probably want to say a couple of sentences about yourself as well.
Yeah, thank you, Leah, and warm welcome to everyone on the call also from my end. Great to see so many of you joining today. My name is Johannes Musalek. I'm Head of Global Sustainability at INEOS Styrolution. And I will be, well, basically acting a bit in the background here, trying to, well, manage the questions and answers section of this webinar. So let me encourage you before we get started that during Leah's presentation that she will kick off in a minute, you have the opportunity to raise your questions in the Q&A module. Depending on the language settings of your teams, this may be called then accordingly instead of Q&A, F&A, or whatever, depending on your language, but I'm pretty sure that you will find it. So please post your questions there. We will reserve some time at the end of the presentation to run through the questions and try to answer them as good as we can. And well, anything that you always wanted to know about mass balance is allowed to be put into the F&A. And with that, let's have a look at mass balance, which is a super important topic, one that may sound a bit technical, but while there are some technical aspects to it, obviously, it is one that is much broader than this. It is a key enabler to, well, in that, transition towards more sustainable practices in our industries. And that's why it is so important to understand what this is all about and then how it works. And Leah has, prepared a very interesting presentation on this. Therefore, without further ado, I'm not going to steal her thunder here. Back to you, Leah, and hope you're going to enjoy the presentation.
Thank you so much, Johannes. Yeah, one more further organizational thing. This webinar will also be recorded. So in case you know of anybody who wasn't able to make it today, but still would like to, learn the lesson, you will find the video on our website later on. So even if somebody couldn't make it today, you will still be able to find everything that you need. Yeah, and then I would say we just jump right in. So yeah, as Johannes already explained, in today's session, we will talk about the mass balance approach. What it is, how we integrated it into our processes at INEOS Styrolution, why it is so important for the industry's transition towards a more sustainable future, and most importantly, how it can help you as our partners to fulfill your sustainability goals. Sustainability is, of course, an indispensable topic in today's day and age. I mean, there is a variety of good reasons why all people all around the world are advocating for a more sustainable future. And I will simply assume that everybody in this call or watching this later on has also thought about ways to lead a more environmentally friendly life at some point, or how to make a positive impact in your communities at home. And I mean, just like we all try to be as sustainable and environmentally conscious as we can in our homes and in our private lives, we at INEOS Styrolution are committed to driving that change on an industrial scale together with our partners. For that, we worked out an ambitious roadmap to tackle the challenges of climate change and environmental pollution. And in that, we set ourselves targets which we believe will be significant milestones in our journey towards a greener future. And just as a brief summary, we want to reduce our yearly emissions by 1 million tons of CO2 equivalents by 2030. We want to increase the amount of our sustainable product sales to 500,000 tons in that same year. And all that, of course, while keeping our standards in product safety and regulatory compliance as high as they currently are. And one of, or more like the key question that we keep asking ourselves when setting these targets and working out our strategies for the coming years is, how can we make our products more sustainable? Our answers to this question are bundled in our eco portfolio. The purpose of this product line is to provide sustainable versions of our already existing product assortment without any compromises in our product's performance. We want to pave the way for a more sustainable industry, and we believe the key here is to make sustainable materials as accessible as possible for our customers and partners. That is why the entire eco product line consists of ready-to-use sustainable solutions. So no compromises in quality and performance. All products have the same chemical and physical attributes as their conventional counterparts. So you can simply switch to our renewable materials and reach your sustainability targets without any need for technological adaptations or new regulatory approvals. We understand that navigating through like regulatory landscapes and all that can be complex and time consuming. And so we want to break down the obstacles in switching to a more sustainable production as well as we actually can. The basis for all that, so for our eco portfolio, is the focus on a circular economy. In the journey towards a true circular economy, the one thing that we need to get away from is our products ending up in landfills and incineration facilities. We therefore want to foster and develop all the different approaches that allow a reintroduction of these finished goods back into the cycle after they've been used and eventually discarded, right? So, and the most straightforward approach here, and probably the most traditional one in the public eye, takes place on the waste to polymer level, which is represented by the two smallest circles on the screen here. That is, on the one hand, mechanical recycling in its traditional sense, which you've all probably heard about in various settings by now, and the dissolution technology. So on this level, we have completely traceable product flows, meaning there are special facilities for sorting and preparing the plastic waste, and there are also dedicated plants for processing the recycled plastic waste again to turn it back into finished goods. So effectively, it is a closed loop that we can physically follow. With the other approaches, however, it is a little more difficult. So here, the materials are being brought back into the value chain at an earlier stage. Processes like pyrolysis, for example, transform non-organic waste streams back into cracker or even refinery feedstocks. These streams of waste, or organic resources actually, but we'll get to that a bit later, are being turned into chemical components that can be used in these chemical value chains again. But that, of course, also means that they are not physically distinguishable anymore from their physical counterparts, from their fossil counterparts, I'm sorry, because they need to have those certain chemical properties in order to actually take part in all the chemical reactions on the way. And that is exactly where the mass balance approach comes into play. But chemical supply chains with all their different levels of production steps can get very complex. So let's not do that to ourselves just yet. Let's keep it easier for now. Think of your outlets at home and the energy contracts that you've agreed with your energy providers for your home. Imagine there are two different contracts for your house, right? So one for the normal fossil energy and one for renewable energy. I could now tell you that the outlet on the left-hand side only provides energy produced in the coal-burning power plant 2 villages down the road, and the right one powers all your appliances with energy produced by a farm of windmills 2 villages over in the other direction. And I mean, that sounds great, right? Then we could just glue the left one shut to make sure no one in our family accidentally uses coal-powered energy anymore, and just keep on using the right one for the rest of our days and all the problems are solved. But it would, of course, not just be our outlets, right? If we truly wanted to follow this principle and make sure those outlets receive energy from separate sources, That would mean you could not have all your energy running via the same switch box. You'd need two separate ones, or maybe even more, assuming you also have your own solar panels on the roof, and maybe even one more contract for energy from hydropower. And it also doesn't stop at the switch boxes. It would be all the cables running in your walls too, and outside of your walls as well. Effectively, we would need a whole separate power grid. The energy being produced at any of these sources, the electrons that reach your outlets, they are one and the same, no matter where they come from. So if we want to keep these truly separate, depending on how they were made, we need to build completely separate infrastructure for each variant. And that, of course, as you can imagine, is not a very sensible or even sustainable solution. So instead of spending effort, time, and money to double, triple, or quadruple all the energy infrastructure that there is, we make use of something similar to the mass balance approach. Again, the electrons that come out of your outlets at home cannot be traced back to how they were made, whether they come from solar panels, windmills, or from burning coal. We don't know that once it's on the power grid. No one can guarantee that your household will be powered solely on renewables or that your neighbors is running only on fossil. But when you have a contract for renewable energy with your provider, you ensure that the amount of energy you use at home is produced and fed into the grid from those renewable sources that you contracted. And the more people make these contracts, the more renewable energy will eventually replace the fossil energy production. And this principle can, of course, be applied to chemical reactions as well. When the feedstocks have the same chemical properties, it cannot be distinguished whether the material is coming from fossil resources, from recycled plastic waste, or from organic resources. Chemically, these are the same materials with the same properties. But with the application of the mass balance principle, there is a way to still trace these non-physical characteristics of our products throughout of our value chains. And that is exactly what makes the mass balance approach so important for the chemical industry. It is a drop-in solution that first and foremost allows its users to replace fossil feedstocks by sustainable alternatives without fundamentally changing anything about the existing infrastructure, right? So this approach allows us to make use of the existing supply chains, the equipment that we have, the flexibility, and of course the expertise we also have in the industry, while also gradually transitioning towards sustainable feedstocks. Because changing an industry, of course, as complex as the chemical one, unfortunately does not happen overnight, so it does need to happen over time. And the mass balance actually gives us the solution to do that. And even after this transition has been completed, mass balance is still the only way we can keep track of those various sustainability attributes of our materials that we're passing through our production chains. This in turn allows the industry to chaperone and grow with the developments without making any sacrifices in performance or regulatory requirements. So basically, we're ensuring a swift and smooth transition towards a circular economy that can rely on supply chains that are just as robust as the ones that we currently have in place for our fossil materials. And of course, by increasing the use of renewable, less carbon-intense materials over time, the industry can also tackle the high product carbon footprints of its materials as quickly as possible. So, all in all, without mass balance, running a sustainable industry is simply not feasible. So we've established that so far. It's just, it can't work. We need this mass balance approach in order to make things work. If we want to use sustainable alternatives as our feedstocks, there is no way around it. But what are these renewable substitutes? There are quite a few interesting approaches out there for various stages of the chemical value chain. So on the one hand, first of all, there are organic resources, such as like renewable oil fractions, like canola or rapeseed or sunflower oil, which can replace crude oil and other refinery inputs. These are more commonly known as bioresources, so that's kind of like the name that they're currently running under. And then there are organic waste products, so the middle category here, such as used cooking oils or crude tall oil, which is a waste from the paper production, or food waste, for example. Sometimes these are also called bioresources. However, the fact that these are actually waste products is quite an important distinction. But similar to the actual bioproducts, these are mostly replacements for refinery inputs, so at a very early level of the production chain. And then as a third option, there are a variety of recycling approaches for non-organic waste. There is, of course, mechanical recycling of plastics applied at the last stages of polymer production. So you remember the two smallest circles in the diagram we saw at the beginning of the presentation. And chemical recycling, which takes several kinds of waste materials and, well, for example, also waste with a higher contamination, be it plastics or even other waste streams, and it makes them chemically fit for industrial use again on an earlier production stage. So we have three categories of material, basically, each with their own advantages, and together they can provide alternatives for each production step in our value chains. Usually, the chemical supply chain, or at least the traditional one, starts with fossil fuel and or natural gas. That is then being processed in refineries into different fractions like naphtha and LPGs. And these materials are then being fed into cracking plants and turned into basic chemicals. These base chemicals are then being forwarded to all kinds of different chemical production plants, such as our styrenics plants, for example. And from these products, our customers can then make finished goods that you all know from your everyday lives and that we all use in our homes. But how does this supply chain look like when we're introducing renewable substitutes? Now, if we switch to organic resources, so the first two categories from the previous slides, those are usually fed in on the earliest production stages, so into biorefineries, which then in turn produce similar refinery cuts that can also be used in the production of base chemicals. But of course, these base chemicals then have at least a partial renewable attribution. The same then, of course, goes for the styrenics production and the finished goods. So we now have renewably attributed materials in our supply chain, substituting the limited fossil resources, but it is still a chain. It is not a circle. And that is where the recycling approaches come into play. With the variety of recycling methods, be it mechanical or chemical, the finished goods can be fed in on almost every level of the value chain again, creating all the different sized circles that we saw at the beginning of the presentation. And now, where is the mass balance in this? Basically, every production step in this value chain is a mass balance system in itself, like the renewable energy grid. Materials of different sources, for example, fossil-based and renewable materials, are being mingled in those production processes to create the materials that our customers need for all the everyday products that we all use. More often than not, we are talking about like liquids or even gases in the chemical industry, with production capacities of several hundreds, maybe even thousands of tons per week. And in a value chain like that, we cannot trace where every single molecule is coming from or going to. That is simply not possible. The mass balance approach, however, makes sure that all the incoming quantities of renewable materials are being translated into a matching amount of outgoing renewable materials then. So let's apply the principles of our energy grid from earlier onto this one. If customers are buying a certain quantity of sustainable material, the suppliers acquire and consume the matching amount of sustainable feedstock into their production plans, and so will their suppliers. And when we then translate that onto the full chemical supply chain that we have here, let's take like a plastic cup, for example. When you buy one at the store, you cannot tell whether its molecules are coming from renewable sources or fossil oil reserves, because the chemical result of all the reactions in the chain will be the same. So the cup has the same color, the same shape. There is no difference to the other cups on that shelf. But with mass balance, we can be sure that the amount of fossil material that would have been needed to produce this cup has been replaced by a renewable alternative at the very beginning of its production chain. And again, the more that is done and the bigger the sustainable quantities are that we are putting through the system, the more powerful and impactful the system becomes. So how does INEOS Styrolution do it then? We incorporate our sustainable feedstocks at several production levels, either into our monomer production or straight into the polymer production, while always, of course, closely following the physical flows of our products. And this allows us to keep our usual levels of flexibility when it comes to customer requirements, and thus also enables us to offer a wide range of sustainably attributed products. The mass balance allows us to pass all the benefits of these sustainable and renewable feedstocks that we bought from our suppliers onto our finished products via a verified bookkeeping system, and with that onto our customers. Now, one might think, if the sustainable and fossil materials we put into our plants are indistinguishable from a physical or chemical perspective, everybody could make these claims and nobody could verify that. But we, of course, want to prove that our sustainability claims are not just empty words, but actions. And the measure for that, as so often, is certification. With certifications, we can verify and validate our efforts via auditing. And for that, we need a standard. By choosing a certification standard, and the word standard implies it already, we make sure that we are acting according to an independently set book of rules. Rules that define where are the boundaries of my mass balance? How do we have to calculate the conversion factors of our production processes? Which renewable materials can we feed into our mass balance? Which sustainability characteristics do I need to keep track of in my supply chain? All of these things are basically decided by the certification standard. And by agreeing to make our mass balance system compatible with that of other players. So we can buy certified product from other companies, knowing that they are applying the same rules as we do. And this set of rules also makes operations comparable. So basically, which asset has the most efficient conversion rates? Which business has the most success in markets of renewable materials, and so on. All that is regularly inspected then by independent auditing bodies. And the results of these audits are made publicly available in the audit report for all of our stakeholders to verify. There are, of course, several certification standards out there that specify on mass balance approaches in supply chain. The one that we are using at INEOS Styrolution, like the majority of the chemical industry in Europe actually, is ISCC+. ISCC is short for, as you can see here, International Sustainability and Carbon Certification. And it basically is a certification system that supports traceable and sustainable supply chains. This standard makes sure that only certified companies can obtain, produce, and sell certified products. So effectively building fully certified supply chains. And in that, it sets a standard for which information on sustainability needs to be tracked throughout the whole certified supply chain. ISCC has 6 overarching principles, which they, of course, require all certified operators to adhere to. You can read up on these in more detail on the official website, but basically they range from protection of the environment over safety and human rights to lawful and good management practices. And with their certification, every system user confirms that their business practices adhere to these principles, and that, of course, includes ourselves as well. As mentioned before, ISCC requires that every actor in a supply chain, every production site, every trader, every storage facility, etc., needs to be certified in order to handle ISCC compliant material. Material coming from uncertified parties can then, of course, not be considered for one's mass balance. To make sure that is indeed always the case, every movement of IECC compliant material needs to be accompanied by a form of sustainability documentation that verifies all the needed information about the material, of course, and about the supplier, so the certified company as well. Material without valid or complete sustainability documentation must also not be considered for your mass balance. Thirdly, IECC, of course, also sets standards on how to calculate the conversion rates of the production processes so that they reflect the actual efficiency of the plants. And then, last but not least, all sustainability attributes are specific and permanently attached to one unit of material. They cannot be changed, and they're being forwarded along the entire supply chain from transaction to transaction. From the very beginning until the last production step. So that way, the sustainability characteristics of the renewable raw material that has been used at the very beginning of the supply chain can be traced all the way to the finished good at the end of the supply chain. As per the IECC standard, we are keeping separate mass balances for each of our facilities, split into the 3 sustainability categories that are being acknowledged under IECC. Those 3 categories actually reflect the distinctions we made at the beginning of the presentation as well. So the first one is the bio category, which is their term for anything with an organic origin. And then there is biocircular products, which covers all of the organic waste streams. And then there's the circular category, which comprises all waste streams of non-organic origins. Under the circular category, we also separate between the 2 possible recycling operations, so either mechanical or chemical recycling. And we also keep track of which sort of waste has been used. So like, is it waste that's been collected from industrial facilities, or is it coming from private households, for example? We're also currently working on providing this next level of detail even for our biocircular materials to make sure that our customers receive as much info as possible about the sustainable aspects of the materials that they are buying. In order to track all these information as precisely as we can, we made sure to integrate our IECC Plus mass balance into our ERP systems. So by now, it actually functions as an automated bookkeeping system. And in addition to making it, of course, more robust against human errors and the likes, this also allows us to provide an automatically issued sustainability documentation with every delivery of IECC Plus compliant material directly into our customer's mailbox. So this way, you will have all the information that you need in the moment that your order has been processed as dispatched in our system. 10 of our sites are currently certified, meaning those are able to offer material under IECC Plus as of today, and more will follow in the future. Every year, all of our active certificates are being reassessed again by an independent auditor, making sure that we are still in compliance with the standard. And of course, all of our IECC certificates can be found on our company website, together with all of our other certifications, or on the public IECC website, together with the certificates of all other system users as well. So there's enough opportunity for you guys to check up on that. And there you can also find all the final audit reports in case you want to have a closer look on that. As mentioned earlier in this presentation, all of our sustainable materials, be it based on physical segregation or on the mass balance approach, are included in our eco portfolio. All our mass balance materials are running under our IECC Plus certification, while our mechanical recycling portfolio is mostly using more common certifications for that area, such as Recyclas or EU Certplast. IECC Plus is not yet very commonly used in this area. However, it is definitely possible as well. So if there's an interest of receiving mechanically recycled materials under the ISCC Plus certification scheme, please just let us know so that we can determine what's best for you on a case-by-case basis. So to give you a bit more insight in how our product portfolio works, so all eco products basically keep the same brand name. However, they receive a letter and a number combination to their name that states the sustainability category and content. For example, the BC70 here, so the part that's marked in green, means that the material has 70% of a biocircular content. And the amount of sustainable content depends on how many of the conventional input materials have been substituted by sustainable alternatives. Products with multiple building blocks, such as ABS, for example, can have, therefore, multiple versions of sustainability content. For the simplicity of this example, we are assuming a 60-20-20 composition of the material, even if that's not entirely chemically accurate, of course, but I don't want to bore you with all the chemical details of our ABS recipes. So if we use this as an example and substitute only the styrene part, then the final product would have 60% of sustainable content in it. And then if we also replace the acrylonitrile, for example, then we can bump it up to 80. And if we also replace the butadiene, then we can bump it up to a full 100%. For the calculations of our actual eco products, we of course use our actual product recipes as basis. And we also regularly compare them to our actual production data. So this way we make sure that our virtual bookkeeping of eco material production mirrors the actual efficiencies of our plants and takes into account like the losses in each production step, because of course it actually happens on a physical basis for the conventional materials, so it needs to be reflected in the production of eco materials as well. Now, if you want to develop sustainable solutions for your products, our eco portfolio offers a wide variety of ready-to-use solutions, and we are constantly working on broadening our assortment here. Our sales team can definitely provide more in-depth information about each of these grades, but all of them are an integral part of our pledge for a greener future. And since these materials do not require any new regulatory approvals or changes in the technical processes, they can be an integral part of your and our customers' journey as well. And I would, I think we've actually arrived at the end of this presentation by now, so I would like to close this presentation with an invitation to check out our eco product website, as well as the sustainability section of our Styrolution homepage, where you can find a lot more detailed information either about our products or about our various projects in the sustainability area. Hopefully I was able to give a proper introduction to the topic of mass balance in our industry, but of course that is not our only approach of a solution when it comes to climate change and pollution. So you're more than welcome to check out what else we have going on there. And then I'm definitely thanking you all for tuning in, for spending some time with us. And I would now like to open the floor for questions.
Thank you, Leah. And well, maybe I can pick up the questions that have already been posted in the Q&A section. And I can encourage you to still continue doing so if there are any questions that you would like to raise. Maybe the first question there, and maybe I can give Leah the opportunity to get some breath here because I can answer a bit of it. What percentage of bio-based monomers are currently used during a production run in the best case? So let me maybe break this down into two parts if you allow. So Leah did show the value chain on an early slide. And well, if we look at bio-based feedstock as such, so the maximum theoretical amount of bio-based feedstock that could be fed, for example, into a steam cracker or fed in at the steam cracker level, that depends very much on the feedstock and its specifications and on the respective installation and so on. But I am not aware of any steam cracker in the industry that is currently hitting any limits on that level. So let's maybe go to, well, the second part of the question that was talking about monomers. And there I assume it refers to the maximum percentage of bioattribution in a polymer. Let me bring Leah in here again. Leah, I think you commented on this on the second to last slide, but maybe you can go a bit deeper into the relationship between a product recipe and the bioattribution percentage.
Sure. So effectively what we look like is what is the input composition of the material, and that goes for a polymer just as well as it goes for a monomer, basically for any chemical reaction. So we look at what is the input that we have, the conventional inputs that we have for the production of a monomer, for example, the styrene in our case, if I may take that as an example. And the input we use for that is ethylene and benzene. And then we effectively look at, okay, what are the quantities that we need in order to produce a specific amount of styrene? And that can be, it depends on the chemical composition in that part. But then you effectively look at what is the percentage of the sustainable input that you have for this reaction of the overall input amount that you have available in order to produce this. And that is effectively the percentage that makes up the sustainable content in your finished product as well. I'm not sure if that goes into the right direction of answering that question. Yeah, so.
Well, I think it did. If not, please post a follow-up question in the Q&A section. The next one I can probably take, because that's a quick one. Are you part of the Catena X automotive network in order to track and calculate product carbon footprints of automotive parts along the complete value chain? Sorry, we are not part of the Catena X network, but we do calculate our product carbon footprints according to both ISO 14067 and the Together for Sustainability guidelines, which are compatible standards to the Catena X product carbon footprint rulebook. So that should probably satisfy requirements of Catena X users there as well. Next one, could you please provide the current price for the ICC certificate? And additionally, are all products currently available as ICC Plus certified? The first part, I guess that's something that you would have to discuss with ICC directly, because that depends on their pricing schemes. But the second layer you can probably answer, are all products currently available as ICC Plus certified at INEOS Styrolution?
We are currently working on getting all products there, but that is actually the overview of what we currently have basically running under our eco portfolio. So everything that is available as what you see down below here as bioattributed products, so the full range, would be available under ICC Plus. We have, like, of all the sites that we currently have certified, we also have all the products there included in our certification scope. So we would be able to make that available if there's any interest in that. And then we can, of course, always determine on a case-by-case basis which biocircular content you're looking for, or bio content or recycled content you're looking for, and what is possible on our end. But yeah, that's basically a broader overview about over what we currently have available.
Very good. Thank you, Leah. Next one I can probably take. When will polystyrene be available in chemical recycling? Yeah, I mean, Leah was showing the different recycling technologies, and the good news here is that we expect that the first volumes of depolymerized, of polystyrene based on depolymerized polystyrene will be available as of next year. So we're working with a partner there who is currently launching their facilities, process here would be you take polystyrene waste, depolymerize it into styrene, and use that styrene again to produce polystyrene. That would be, then again, according to our performance up footprint down claim, that would then also be available in sensitive applications like food contact applications. So this is going to happen in the first part of next year, obviously at well, relatively low volumes, because all of this, as usual, will scale up into bigger industrial scales. But we are basically right in the startup phase of this, and we're really looking forward to this, and we're super excited about it. Next one, again, with a more mass balance oriented direct focus, that goes back to Leah here. And it talks about site or credit transfer systems, cross-site transfer and so on. Are there different credit transfer systems for different advanced styrenics and the possibility to choose which one? Or is it possible to choose a more or less strict approach to allocation of sustainable content? So maybe Leah can comment a bit on our approach to particularly cross-site transfer here.
Yeah, sure. So in general, under IACC, there is an option to basically transfer credits from between sites if there's no physical connection between those sites. It is quite a strict set of rules, so it's very limited that you can do that. In general, it is allowed. However, if that's if that happens in the supply chain at some point, that needs to be indicated and on all the documentation of all the following transactions, so that whoever actually buys material that is based on that knows that there has been a link, like a breakage of the physical link of the material at some point in the supply chain beforehand. We as INEOS Styrolution actually decided that we do not want to use that. So whenever you are buying material from our sites, you can be sure that we will not make use of these non-physical credit transfers. So we always follow the actual physical flows of our material, because we think that's a very important thing to do, to make sure that there is indeed a chance that the renewable raw material that's been used at the beginning of the supply chain actually also physically ends up in the very end product that you want to produce as well. So and that's something that we have decided for ourselves, and that is also always visible on all the documentation that we're issuing, because as mentioned before, if that has happened, there needs to be an indication on the sustainability documentation, but the other way around, if it has not happened, you will also be able to see that on the documentation. So that is something that we decided for ourselves, for our company, to not make use of, even though it is, in theory at least, an option under IACC+.
Very good. Very clear. Thank you, Leah, for that. And I think that's the last question that we had. So looks like right on time, we would be able to close the meeting, and I will leave this to Leah then. Back to you.
Yeah. Thank you so much, everybody, again, for all the questions, for joining. If there's anything that you would still like to ask or that's not clear, well, either get in touch with your normal Styrolution contacts, and they will probably refer them to you, or check us out on the websites, on the links. I guess, or at least I hope, that you will find most of the information that you're looking for there as well. So yeah, thank you so much, and enjoy the rest of your week.